Hello everyone, this is my project Microwave Oven Simulation. This is a part of our internship. I am Navyasri, studying in BTech third year currently from BVRIT Hyderabad College of Engineering for Women from the Department of Electronics and Communication Engineering.
Let us look into the topics that are learned during the internship. The first one is Introduction to Embedded C, Introduction to C, and under C, we have learned conditional statements, loops and operators, arrays and pointers, storage classes, preprocessors, functions and strings, MPLab IDE, XCD, PixSimLab, and Disha Workshop being the last one.
The contents of this presentation will include introduction, a basic insight into embedded systems, the block diagrams required, the requirements of the project, how a basic embedded C program looks, PixSimLab, CLCD, tactile switch, matrix keypad, ISR, timer, and the final project implementation.
Under the basic introduction, let us see what a microwave oven is. It is a relatively small box-like oven that raises the temperature of it by subjecting it to higher frequency electromagnetic fields. It is used in kitchen like to reheat and cook food, disinfect kitchen items, make citrus fruit juices, heat beauty products, roast garlic and decrystallizing honey are some of the examples where microwave oven is used.
Microwave oven has basically three modes. It operates under grill mode, convention mode, and start mode. A grill mode is basically simply used for grilling. There is a grill heater placed at a specific location inside the oven, which is used for the grilling effect, and it is used mostly for meat and other items. It gives the same effect which you often see on barbecues. And the other mode that we use a microwave oven for is the convection mode, which is used for baking cakes and cookies. In this mode, the heater is on and the fan provided inside the microwave oven circulates air throughout the chamber and it gives a baking effect to the food placed inside it. There is another mode called start mode. This is just used for starting the operation of the microwave oven, and it has a 30 seconds timer, and you can increase this timer whenever you want using a particular key, which we will be showing in the future implementation of the project. So basically these three modes are the mostly used ones, and the start mode is simply used to start a 30 seconds timer, which is used for heating the oven.
In the internship progress, we studied about embedded systems. So let us first see what an embedded system is. It is a combination of computer hardware and software designed for a specific function. It is also a function within a large system. The systems can be programmable or have a fixed functionality. They are used in industrial machines, consumer electronics, agriculture and processing industry devices, automobiles, vending machines and toys, airplanes, mobile devices, and there are many more locations where embedded system is used. These are some of them.
The most common embedded systems that we see in everyday life are ATMs and traffic lights. These are very commonly seen and are used in daily life, and ATM are used in banks and other financial institutions to allow customers to withdraw cash, perform transactions, and check account balances. We know that ATMs are very important and a vital part of our usual financial life. Traffic lights, on the other hand, are also embedded systems that are used to control the timing and sequence of traffic lights at intersections, crossings, and other places, which ensure that the vehicles and pedestrians can safely cross the road. These are just one and two examples of embedded systems, but embedded systems are very much used in everyday life and have a lot of importance to improve our quality of living.
Let us see the block diagram of an embedded system. The main unit is CPU and the other blocks are sensors, A to D converters, D2A converter, actuator, memory, ASIC, non-digital hardware, software, human IF port, diagnostic port, auxiliary system, power cooking, and the signal received in the sensor is given to the ARB converter to convert the analog signal to digital, and actuators do the reverse of it, like it converts a digital signal to an analog signal, and the CPU requires a memory, so we have a memory block, and likewise we have software. We also have some ports like human IF port and diagnostic port, and auxiliary systems, and ASIC or FPGA non-digital hardware is also given as an input to the CPU.
Now let us look into the block diagram of a microwave oven, which is the main point of our project. A microwave oven has several components, and a few of them are microwave source, stabilizer, frequency standard, frequency counter, scope, recorder, printer, computer, square wave modulator, mixer, detector, vacuum line cell, square wave modulator, which is given to lock-in amplifier, preamplifier, and a final scope. A few components out of these can be explained as mixer. It performs mixing operation of two signals. That means it has two operations. It can do an up conversion or a down conversion, but in usual appliances, we mainly use down conversion, which means the mixer will produce the difference of two signals. Then this is given to a cell, which is given to a detector. A detector is basically, it acts as a demodulator, that means it demodulates the modulated signal. This is given to the preamplifier. The preamplifier amplifies the signal to the required frequency and amplitude as per requirement of the and performance of the device. It is amplified before sending it to the modulator or lock-in amplifier. That is why we call it a preamplifier. Now we have a square wave modulator, which is used to modulate the square wave input. And we have other components like stabilizer, frequency standard, printer, computer, recorder. And a frequency counter also is used for counting the frequency of the wave that is generated inside. It counts the pulses and gives the output. These are the basic blocks of the microwave oven.
Now, let us see the requirements in our project. The first one is MPX ideal X8 compiler, where we compile the program. PIC-SIMLab, where we write the code. PIC16F8 WNA microcontroller. It is used as a microcontroller in our program. 16x4 CLCD. It is a display screen. NKB. Timer 2. Tactile switch. Timer 2 is used as a clock, and tactile switch is used as an on-off switch.
Next, here we have a basic embedded C program. First one is modules.c. Here, as we know, an embedded C program is used basically by C programming itself. We use all the components and all the functions from C programming, but it is used for embedded C applications. So we have modules.c, which has hash include, and we have supporting underscore files.h, which is the header file. And next comes the void function, and inside the parenthesis we have to include the function code. Next is the main.c. Here we have hash include main, void function, and we initialize the code. Basically here we are using functions from C programming. So the next one will be void main of void. Here we have to write the entire code and we initialize it, we get the output.
And the other two blocks are main.h and modules.h. And the main.h, we first define a function, and then we write the function in define main underscore h, and we open the hash include http.h, and in that we include our code and then end it. And the modules.h, we first import the file, like supporting file in this code, and under define supporting file head, we write the code and then end it.
The next, here we can see the PIC-SIMLab window. This is the basic window that we find, and we have obtained it after making our microwave oven. This is how the window of PiximLab looks like after microwave oven application.
Now, let us see what a CLCD is. CLCD stands for Character Liquid Crystal Display. It can display numbers, letters, and punctuation. It is generally used as a display. It is a user interface between the machine and the user. It can find this. You can find this type of display in other products such as vending machines, 3D printers, data logger, etc. In PiximLab, there are two types of display: 16:2 display and a 16:4 display. These are the sizes of this display screen which is being projected at the output. And in our project, we are using 16:4 display.
So the next component is tactile switch. These are very commonly used in many hardware applications for developing several circuits, and as a hardware product, this is very cheap and accessible. A tactile switch is basically an electronic circuit that typically works when pressure is applied to the device by the user. This gives the user a perceptible click or hamtic bump in response, indicating that there is a current flow through the circuit. Current flow will be turned off when the switch is released. And to explain in short, we can say that a tactile switch is a momentary action device which operates by the perceptible of touch. This is basically just very similar to the switches that we use at our home to turn on lights, fans, etc.
Now, let us see what a matrix keypad is. It consists of push button switches that are located at the column and row intersections of a grid or matrix. Switches in the same row are connected together, as are switches in the same column, which means the switches in the same row are getting connected together, and the switches in the same column are also getting connected. Like in the besides figure, we can see it in row number 3 where the switches are getting connected, and when you press a switch, it connects a row to a column.
The next we have is interrupt service routine, which is a software. An interrupt service routine, which is also called as ISR, is a software routine that hardware invokes in response to an interrupt. So this ISR actually examines an interrupt and it determines how to handle it, executing the handle, and it returns a logical interrupt value. If there is no handling required, the ISR notifies the kernel with a certain return value which is inbuilt. In this interrupt service routine, all the other interrupts are disabled till the routine completes, which can cause a problem sometimes if any other input is received, and it will be held as pending. This condition is called as priority inversion, and it should be avoided.
Now, let us see what a timer is. A timer is a specialized type of clock which is used to measure time intervals. Timer or counter are a part of microcontroller internal hardware. Timer, controller, counter are same as per hardware point of view. Time is referred as change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar. Timer is used to generate delay and count each for counting external events. In timer, like we use it as an alarm or a clock. We set the timing and the process will run in that particular timing.
Now we can
Now let us see the working video
of the microwave oven project. This is the main part of the project presentation. Here we have a pre-recorded video that we have recorded of the operation of our project. As a part of the internship, we developed this project and we have written the code as per our classes and as how we learned in the internship. Here is the entire code that we wrote. It is an embedded C program, and we wrote this code with the help of our mentors. They taught us how to write several instructions to the microcontroller and microprocessors. So this code has inbuilt functions and it returns, after running it returned a build successfully prompt. Now we have to go to the Pixim lab, and here we are loading a hex file. Loading this hex file into the microcontroller, we get a prompt saying that the microwave oven is turned on. It gives the first 4 cooking modes which are inbuilt, which we wrote in the program. First one is micro, second is grill, third is convection, and fourth is start. Accordingly, we have to press the numbers in the tactile switches. The first switch is for micro. It shows that the power is 900 watts. And now we got this on the CLCD. Now we are setting the time to 5 seconds. Setting it to 5 seconds and clicking hash. Hash is used to click enter. Now after 5 seconds, this fan will be keep running and it will stop. We can use 5th button to press stop, to press pause, and then the fan is paused. Now 4th is for resuming. As you can see, 5 seconds is done, so we get a prompt saying that the cooking time is up. Now we have to go back to the main menu. After going back to the main menu, you can try the second one. The second is grill option. That means the microwave oven works in the grill mode. So clicking second button, we got the same CLCD screen. Now we are setting the timer to 9 seconds and clicking on hash. The fan is running. We can see that the timer is changing, and if you open the door, you will get this prompt. The buzzer sound will come, but because of internal issues, we couldn't capture the sound.
Now, let us see the temperature setting. If the temperature is above 250 degrees Celsius, then we will get it as invalid temperature. So let us check for temperature like 300 degrees. We got the output as invalid temperature. Now, let us get back and get the temperature as any number. Like here, we are giving 2. And we'll start the process. The preheating has started and the time is automatically set to 180 seconds. So for our video, let us pause the timing and we'll get back at 10 seconds. Now we are at 9 seconds. We can see that the timer is running. And after the time is up, the preheating process stops. And now here this is about the timer. The timer will automatically be set, like we have set it here to 5 seconds. We can see that the fan is turned on and the timer is running. Once the timer is up, we get a prompt saying cooking time up. And now we get back to the main menu. Now let us know about the timer. Like starting the process. And initially the timer will automatically be set to 30 seconds. If we want to increase the time, we have to press key 4. So like in the video, we can see the timer has changed from 27 seconds to 57 seconds. The fan is running. We press 6 to stop the process and get back to the main menu. This is the working video. And thank you, everyone.
So this is the complete demonstration of our project. Thank you.